All right, so like I had promised you earlier, I wanted to talk a little bit about the telephone directory assignment, especially because I think it's a really good assignment to work with strings. You can use everything in there can be just strings. And then you have to compare to method that does everything for you. Well, not everything, but certainly simplifies a lot of the work. So here, David Chen was generous to let me show you the whole application, all the code for each of the classes. Let's take a look first at the design that he came up with. Um, First, he created an ADT called telephone with his initials, which I appreciate that tremendously because when I download all the programs, if you guys have the same names, like telephone, let's say, they get overwritten, and then I lose everything. I only get the last copy, the last version. I many times I go back and refer to specific assignments by looking at the outcome and of the results that you guys do, and I kind of go around and make some changes. Telephone is a telephone directory is a really good assignment. I don't remember the source of it, but I thought that this could give you an insight on how to actually make a string class very useful. So let's go straight to the code. So telephone is right here. So he copied and pasted the actual assignment, just like I ask everybody. That is your documentation at the top of the header, and name and version and date, which is fantastic. So as you can see, the telephone class, the telephone ADT, is very short. This is it. All you need is name and a number. And both of them are strings. This will enable him to pretty much do all the sorting and the searching with strings. Since he used the same name for the arguments as the instance fields, then he used the this operator to identify or tell the compiler, I should say, which of these two refer to what. So the one on the left refers to this particular object that is using, and that's what the keyword this is so well used, the name. And this one on the right is the one coming from the argument. This is a local variable. It only exists in this scope. Only one constructor, he doesn't need more than one. And then he has the accessor methods. This is all accessing information. There is no changes to any of the instance fields. As you can see, these are private, so each object of telephone are always treated equally, consistently. Get name, get number, and then he has one of, I don't get gibberish. I get something very much relevant to what the class is about. And in this case, the name and the number. Also, this will simplify work when you actually have to print because you don't have to build a whole, other method or other piece of code to actually get this information from the object, like get name, get number. No, you can do it just right here, and you can use the instance fields. So before I show you the second class, let's take a look at the driver. The driver is very straightforward. So he creates an object of something that he calls telephone directory, which we're going to look at it in a minute. Once it's created, as you can see, the constructor does not have any argument because, well, we're going to see that in a minute. It doesn't need it. But the thing is that it's going to be doing searches. So what does this constructor do? Here's the constructor, Here's the constructor, and this is the data type. Make sure you understand the difference. The operator new calls the constructor, And what's on the left is the data type of that object. So let's take a look at this second class that he built, that he designed and then implemented. So he has the telephone, very raw data, very small amount of data, very specific, it's very cohesive. Then he used the telephone directory, meaning the telephone directory is going to need objects of telephone. BlueJ shows you how it's actually, in fact, needing it. So this is called coupling, right? So let's take a look at what the telephone directory, because we saw that the driver all it does is create an object of this telephone directory, and then it does the searches. So that means that most of the work is in this class, this ADT, abstract data type. All right, so I'm going to get this bigger because we kind of seen what happened before. I think everybody learned how to use files, which is something that is not part of the curriculum, but it can really simplify your life so much. So you don't have to do the input in a regular basis every time you test them. So you just load the information into the arrays. You can take a different file. It's probably one of the best things to do. I think it should be part of the curriculum. It's not that difficult to learn, and it's always exactly the same. What's important is more or less what everybody had done is this part. By the way, there are a lot of good applications out there from you, the rest of the students. Some of them were a little bit more work, a little bit more complicated. I think this is probably the one that is very straightforward, and yet it has everything that makes it work well. And it's very condensed, compact. It's readable too. I will show you how little documentation you need for something that can be read very easily. So the constructor opens the file with the data, and within the constructor is going to do all of this. Take a look. This is a really juicy constructor. And since it's only going to be done once, it is a good place for this code. That's the splitting. So you can separate all that information. And then it creates a telephone with what? Well, what do we need? Let's go back over here for 1 second. His instance fields are 3 arrays, and they are of 100. That's the length. Directory will have always the original data. Sorted names will have data that was sorted by names. And the sorted nums array will have the data sorted by numbers. Now, once this is done, these 2 arrays created, then you can do any search you want. So how is the directory created with the raw data? So once it's split, we have the values over here of the splitting, and it's going to take the value is the second one, but the actual hold on a minute. The first one is, I believe, is the name, isn't it? Or the last name. Yeah. And then here's the telephone number. Am I right? I'd like to confirm that. Let me see quickly if that's correct. I think it is. But it doesn't hurt to check. Remember, any data files that you use, make sure that it's wherever the package for BlueJ has it. Oh, here's the data. Right, so we have last name, first name, and then the telephone number. Very good. All right. So now we know how we created an object of telephone, which we know that is expecting the name and the number. Everything is a strings. Separated with spaces for the first and the and the last name, and then the value of the telephone number. Closes all this, a try and catch is a really good thing to do. I think you already know that because I had given you the code for that. Then sort by name and sort by number is done also in the constructor. Again, this is something that is only done once. This is what makes the binary search worth it, because you sort only once, but then the search can be done as many times as you want to. That's the efficiency of it. Do I need more documentation than this? No, I think this is good. He tells me he's creating objects of telephone. Then the names of each of the methods already tell you what they're doing. And then when we look at each of the methods, here we go. Copy unsorted values to the sorted names. So it's going to take directory, which is an array of the raw data, and it's going to put it one by one to the sorted names array. Remember that you got to do it one by one. That's number one. Number two, make sure that you always create the arrays before you do any copying, because otherwise it's going to copy the reference. He chooses the insertion sort. He feels comfortable with that, which I think is terrific. If you don't remember how the insertion sort works, it will be good to freshen up on that. I haven't seen anything that it says anything about sorts, but I mean, if you are in AP Computer Sciences because you're interested in programming, so at least know one sort. This is what I told you when we were learning about sorts. So how does that work? How the insertion sort works? Well, I know all of you know it already, so I'm going to be very quick. It's going to go from left to right. He starts at position 1, which is the second element, because it's going to keep on going to find the position that that particular number belongs to, including up to j minus 1. J is going to be whatever value I is, 1. So here, you have to make sure that you don't end up with something less than 0. And because you want to reach that point anyways. So it's going to the right. Here's the array, sorted names, sorted by names. It gets one element, which is an object of telephone, and calls the method getName. GetName is a string. That means that now I can use the compareTo method. Here it is. And what is it going to compare it to? Well, it's going to compare it to the one before in this case. This would be 0 the first time around. So if I click on this, we can see that, it's not showing, but this, here it is. Oh, there we go. There. All right, so if it's less than 0, meaning the one on the left is smaller than the one on the right, if these two conditions are true, j has to be greater than 0, because as you can see, the third part of this for loop, j is decreasing by 1. So you don't want to go past 0 as you go to the left. Not shifting, but looking for the position where you're going to put the value that is smaller than the one you just had there in that position. And then it does the the swapping over here when that happens, or the shifting in this case. As you can see, it's j to j minus 1 to j, and then j minus 1 will have the temp. So that's the difference between the insertion and the selection sort. The insertion is going to look where that element belongs to and shift everything to the right. The selection sort swaps values. If you found something smaller than whatever I had to the left, then it's going to be swapping positions. Well, here is the interesting part. Technically, this is exactly the same. The only difference is that instead of getting the name, well, we get the number. And so since this is not just an alphabet, right? The strings works with ASCII code, Unicode, and so it's a lexicographic order, which includes dashes. In this case, there are dashes in a number, right? Does the data have parentheses? I think it does too. So everything works out very well. So we have the two arrays. By the time the sort took place, sorted nums has all the lines, the elements of the array sorted by number, and sorted names is going to have the whole array sorted by name. So how do we do the searches now? Well, he's using the binary search. This gives a lot of advantage over doing a linear search, which that will take, it's like almost like brute force. I would say that it is brute force because it looks through everything. Well, he is going to actually simplify the amount of work and therefore increase the efficiency of his search. And hopefully, and I believe you all know how the binary search works. And if that was one open-ended question, let's say, remember the story that you tell and the binary search. If I had known College Board was going to give those type of open-ended questions, we would have told more stories. Maybe less picturesque, because a lot of you work very hard on telling me good stories. A shout out to Zach. He had a good story there. Anyway, so the binary search, like the word binary says, it means that it's going to be splitting things in half, binary 2. So it's going to go from the middle. The middle is low plus high divided by 2. This is at integers. It could be that you have, let's see, if you have 7 divided by 2, it's going to give you a 3. And on the other side, you're going to have 4. So there will be a little bit difference, but the efficiency is not going to change just because there is one more element on one side than the other. And this is exactly just like the binary search. There is nothing different here than that. And then he does the same thing for numbers. So here's for names and here's for numbers. As you can see, documentation is minimal, but it doesn't lack information. So I would say that it's concise, it's precise. That's all we need. When I ask you for documentation, and I told you many times, I want you to write a book. Just give me indication of what you're doing. Does he need any more than this? No, because it's straightforward. When do I want more comments? Well, when you do something kind of sketchy, some people call it, and you're twisting things around, blah, 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 that's when I need more information about what you're doing. So I don't scratch my head and I spend 20 minutes trying to figure out what you're doing. So there is not much to it. That's the full story. It's actually not long. It's short, and he actually has his test data. His test ran over here. He did it by name, by number, by name, by number. As you can see, it looks really good. Clean, easy to read, and easy to follow. For those who are still stuck on this business of designing classes in which we talk about coupling and cohesion, this has low coupling and high cohesion. All right, I hope to see you later, 6 o'clock either tonight or tomorrow. This also will be a good chance for you to ask questions about David's program. I would like later on, after the AP exam, maybe after all the AP exams, is to have a small short videos of other ones because there are more than one good program, but I just couldn't put them all up here. And I would rather have you doing it. I didn't give enough time for any of you to actually do this, but it's not over. So I will ask you to do a specific ones and go back and look at it. And I think that's important to do in programming, which is look back and see how you could have done things differently then, but now you know better. I'll see you soon. Bye-bye.